Hello dear students, today I will discuss about derivatives. Just in the previous class we have seen that the limit of a function. Okay, so limit of a function may exist, may not exist, at some point. So here derivatives also related to the finding of limit. Just like suppose we are having function fx. So changes in fx with respect to the changes in x. So suppose here x is the variable of the function. So x changes in x is delta x. Then changes in fx will be what? Corresponding changes will be this. Changes in x. Changes in fx is like this. Clear? Also, we can write like this: y equal to if fx, then f changes to fx. There is a small changes in x, delta x. Then there will be also small changes in y. If small changes in delta y, there are the changes, small increment. Then y plus delta y is equals to, also we can write like this. Then changes is function, that is function fx. What? Y, delta y. So we can find this minus this. Okay, so this is 2, this is 1. So 2 minus 1 gives what? This minus this, y cancel, delta y is equals to what? Fx plus delta x minus fx. This minus this, we can get like this. Now this is the increment, changes in y means what? Fx. Changes in fx. So that is, now if we want to find the changes in y with respect to changes in x, then we can divide both sides by delta x. Just divide it. Now this ratio defines changes in y with respect to changes in x. That is like this. Okay. So sometimes delta x is written like this, h, and then we can get values fx plus h minus fx upon h. H equals to what? Changes in x, that is delta x. So here if we take for a particular point, just x is changes, this in this line x is changes, in this line y is changes. Okay, for a particular point, what is the changes in y with respect to x? For finding that, just we have to take limit here. So its limiting value when delta x tending to 0. Its limiting value, just like this, limit delta x tending to 0. means just at a particular point, at an instant. For finding changes in y, just we have to take limit delta x tending to 0. Here also we have to take delta x tending to 0. This type of formula is used for finding derivative, and this is just delta to d y by dx, and this is limit delta x, sometimes written as h tending to 0. So fx plus h minus fx upon h. Okay, so this is the derivative of y. It is called derivative of y with respect to y means what? Function. So derivative of y with respect to x is defined like this. Okay. Here, for a particular point, we can define derivative. We can understand very better for that discussion. Just see. If fx is a real valued function and fx is real valued function, just we take real valued function, and a, suppose a is a point in the domain of function, because whenever there is a function, whenever a function is defined, then there is a domain of that function. So a is a point in the domain of the function, then the derivative of the function fx at the point a is defined as denoted as derivative f dash a, f dash at a, dash for derivative, and defined by, function is defined and x is where a is a point of domain, then derivative of function at a is denoted like this, and f dash a equals to is a limit h tending to 0, h a plus h minus f, h tending to 0, f a plus h minus f a. Here value of the function at a, value of the function at a point, value of the function, and some increment in this point, so h, some increment. After this is a point, this is a point, small increment h, and at this point the value of function is this. Now difference of this two value, f a plus h minus f a, f a plus h minus f a is divided by difference of this a plus h minus A. That is H. That is what? H. H. This is. So changes in function value of the function at an small increment in the value of variable, that is A, that is point A. And this is called derivative at A, because changes in A just plus H. Here Fa changes to Fa plus H, corresponding changes. And now this changes divided by these changes, that is this by H. When we tend H tending to 0, we take nearer to the A changes. That is limit H tending to 0. This is derivative at the point A. So H tending to 0, Fa plus H minus Fa upon H. Okay, defined by this, provided limit exists. Because we know limit always, it is not necessary to exist. So just you have to write also after this, provided limit exist. Provided limit exists. Okay. So provided the limit exists. Clear? So this limit is known as the derivative of the function f at a. That is here fx is function and a is any point. At the point a, derivative of the function is denoted by like this, f dash derivative, f dash a. And at the point a, here a, h tending to 0. So remember this definition. Okay, derivative at a point. Clear? So we know how can find the value of limit. Some rules we have already studied about. So just you have to find the limit. This limit. If we can get a definite value, that is provided limit exists. That is, if limit exists, we can get a definite value. That will be the derivative of the function at the point a. Okay. For example, suppose let fx equals to 2x plus 3, and we have to find the derivative of f x at x equals to 1, x equals to 1, at point 1, x equals to 1. Then we will find what? F dash 1, f dash a, f dash 1. Now f dash 1, therefore f dash 1, f dash 1 equals to what? Limit h tending to 0. H tending to 0, f dash 1 means a. In place of a, just you have to put 1. So f 1 plus h minus f1 upon h. Now our target is finding this limit. The definition of the function we will use from here. Fx equal to 2x plus 3. Clear? So just see, limit h tending to 0, f1 plus h, f1 plus h, fx in place of x 1 plus h. So 2 1 plus h plus 3. So 2 1 plus h plus 3. So this is the value of what? f1 plus h. 2 1 plus h plus 3 minus f1. Here 1, 2 into 1 plus 3 minus 2 into 1 plus 3. This upon h. Now just we'll try to find the limit. If limit exists and we can get a value, then that will be the derivative at the point 1. Okay, so here see, so this implies f dash 1 equals to limit h tending to 0, 2 plus h plus 3, 2 plus h plus 3, 2 plus 2h, sorry, 2 plus 2h plus 3 minus 2 minus 3 upon h. So here we see that 2 cancel, 3 cancel, 2h by h. So implies h tending to 0, so 2h upon h. So this is equals to limit h tending to 0, 2. 2 is constant, so 2. So derivative is 2 at the point 1. Okay. So simple. Derivative at a point can be found by using this formula at the point A. Okay. Now for finding derivative, just at the time of finding limit, you can use any of the formula for finding limit of function as previous we have discussed. Okay. So this is the definition of derivative of function at a point. Okay. Now just we will see what is the geometrical interpretation at this the derivative of a function at a particular point. Okay. So geometrical interpretation of the derivative at a point. So here just for that we have to draw a diagram. Just see, because derivative is very, very important topic of the calculus, because main thing is derivative from which we start our study of higher mathematics. Okay, very, very important derivative. So just let this geometrical interpretation. Okay. Geometrical interpretation of derivative at a point. Okay. Let y equals to fx be the function and consider on the following diagram. Okay, let y equal to fx be the function and consider on the following diagram. So here x-axis, this is y-axis, this is origin. We know the graph of the function is a curve in 2D plane. So suppose this is our graph of the curve. Okay. Y equals to fx curve is this. Okay. Now take this is a point A. Okay. And this is just increment here A plus h. A plus h means this is the value of A and this is h increment in this point. And if this is A and this will be the point, suppose this is P point, its coordinate will be what? A, F. This point, because this is x, value of x, and this value is what? Fa. This is Fa. This is Fa. This is A. This is Fa. So this point is P point. Suppose point P is this. Now this is the value of A plus h, and okay, this is A plus h. So this value is what? F A plus h. Value of the function in this direction, y-axis. So suppose this is point Q. X coordinate A plus h, and y coordinate for this point Fa plus h. F A plus h. This is the coordinate. Okay. So here we see that if we draw parallel line to here, like this, horizontal line to x-axis, this is parallel line, and also this is parallel line. This value is what? Here Fa. This value is where? Fa plus h. Okay. Now perpendicular to here, just we are drawing like this. This is point. This value is what? H. Because this is h. This is h. H increment. So this is also h. Clear? Now, suppose this is PQR. This is R. Suppose. Okay, because this is curve, this is point, corresponding points. Now we have this PQ can be connected. This is a chord. Suppose PQ is the chord. Just PQ chord. And this is tangent. Okay. At this point, this is tangent and this is chord. Just we know, suppose this is curve, this is a chord, AB chord, and as we tending to come to B, from A to B, that is, if A comes here, then this will be chord here, then this will be chord here, then this will be chord. So this chord will tends to a tangent when A tending to B, just like this here. When Q tending to P, this chord will tending to tangent. So this line is tangent. This is T1. This is, suppose, S. This is T. ST is tangent at the point P to the curve. Point A at point A means at this point. The tangent of the curve ST. Tangent, this chord will be tangent at this point. When Q tending to P, just like this. Here Q, here P. When Q tending to just this is chord here, here. Finally, this will tends to converge as Q tending to P. So here as Q tending to P, this chord will be tangent. Now, we know the definition of derivative. Just see. We know derivative of f at point A is equals to what? Just we define what ratio? Limit h tending to 0 f a plus h minus f a upon h. Okay, just see up to this, accepting this like this. See, f a plus h minus f a. This is, we know derivative, definition of derivative is this. Now just see only this portion, f a plus h minus f a. What is the value here? Q1. Here Q1. This is f a plus h. This is f a. So this value, this value what? F a plus h minus f a. This value is, so Q1. This is equals to what? Q1. That is Q1, this side. And this value is what? H. H. And in this triangle PQR, in triangle PQR, QR divided by PR, QR divided by PR, PR, QR by PR, this is QR by PR in the triangle PQR, this triangle, in this triangle. So what? Here 90 degree. This is 90 degree. So this is hypotenuse. Now, if this angle is psi, tangent makes angle psi. And if this angle is psi, because these two line are parallel, so this is also psi. Now, in this triangle, when in this triangle, but for this triangle, this angle tending to psi, when Q tending to P. Okay, at this that stage, just we see where Q just we tensed Q to P, then this chord will be tangent. But before tending, just in from this triangle, if this is angle, then the front side is what? Perpendicular, or this is base. So perpendicular by base, that is 10. So 10 of this angle. 10 of this angle. This angle tending to psi. If tangent makes angle with x-axis psi. Tangent, this line will make tangent. That is, this angle will tending to psi. That is tan psi equals to this upon this. And what is this? Tan psi, we know, slope of the chord. Slope of the chord. Chord tending to tangent. When? Chord tending to tangent. If Q tending to P. If Q tending to P, then QR tending to 0, and this is tending to also 0. That is H tending to 0. H tending to 0. So H tending to 0, that is here we can write Q tending to P. Q tending to P, that means what? Limit H tending to 0. Q tending to P means H tending to 0, and QR means this F A plus H minus F A upon H. Okay, and this is what? This is after tending, chord will be tangent. So tan psi. Tan psi. And this is defined as f dash. So this is equals to f dash. That means what? Tan psi slope. Okay. So we can write the decision as derivative at a point A is slope of the curve of the tangent to the curve at that point, because tangent at this point and slope of this tangent. So slope of the tangent at the point A shows the derivative. That is, derivative shows the slope of the tangent. Okay. So here our geometrical meaning just very simple. Derivative at point A, what shows? Derivative at a point A shows the slope of the tangent. Slope of the tangent. Slope of the tangent at a point A. Slope of the tangent at a point A, tan psi. At this point, tangent, slope. So tan psi. This is equals to f dash. So derivative shows slope of the tangent at a particular point. Derivative at a particular point shows the slope of the tangent at that point to the curve. Okay. So this is or geometrical meaning of derivative of a function at a point. Okay. Now, just we will define the general derivative, that is, if a function having derivatives at each point of its domain, that is, if derivative exists at each point of its domain, then we see that the derivative is again a function. So, general derivative we can define like this: if derivative of a function fx exists at each point of its domain, then it will be a function of x also. And in this case, we can define a derivative in that domain as f dash x is equals to limit h tending to 0, here f x plus h minus f x upon h. Here this exist, that is limit exist, provided limit exist. Clear? So this is the f dash x. Just finding limit, you can get a value of function of x. Clear? So, see, for example, let fx equals to x square. Fx equal to x square. Then f dash x limit h tending to 0, fx plus h minus fx upon h. This is the definition. Now, just we write the value here, limit h tending to 0, fx plus h, fx equal to x square. So x plus h square, x plus h square minus x square, fx plus h minus fx, x plus h square minus fx x square upon h h tending to 0. So this is equals to what? X plus h square. So x square plus 2xh plus h square minus x square. Just after solving we get like this. Now here x square cancel. Limit h tending to 0. 2xh, h common, also we can take a common 2x plus h upon h. X square cancel, h common 1h, so 2x plus h upon h. H cancel, 2x plus h, so limit h tending to 0, h cancel, 2x plus h. Now you can put the value 2x. So 2x, this is the answer. This is the derivative. F dash x equals to 2x. Fx equal to x square. So f dash x equals to 2x. That is, derivative is again a function of x. So this is general derivative, okay? So derivative of function. By using this definition, you can find derivative of polynomial, trigonometric function, just like sin x, cos x, tan x, and so on. Okay. So this definition is called first principle method. First principle method. First principle method. Okay, this is called first principle method. First principle method. Derivative by using first principle method, that means this is definition. This is called derivative by first principle method. Just like this, you can find the derivative of a function in terms of as another function of x. Okay, if derivative exists at all the point at its domain. Okay, so let us try to find derivative of sin x what is the derivative of sin x, because now we will find some formulas of derivatives. Okay, this is very important formula for class 12th. So here just see what are the derivative of sin x. Just we have to find, just like trigonometric function. Let fx equals to sin x. Then according to first principle method, according to first principle method, f dash x equals to. There are also different type of notation for derivative. Just dy by dx, y equals to fx is our general notation for function. So derivative of x, fx with respect to x, this. It can be also written as d fx by dx. It can be also denoted as dy by dx. This is d by dx, that means what? Derivative with respect to x. So derivative with respect to x of the function fx. So we can write like this. Fx means y, also dy by dx. We can write dy by dx can be also dy dash. Also it can be written as f dash x. So these are the different notation for derivative of fx with respect to x. At a particular point a, so we are writing like this, what? F dash a. Here also we can write f at a. Here also we can write at x equals to a. We can write at x equals to a. The derivative. These are same. Okay. So this type of notation can be also used for derivative. Okay, here general derivative, that means f sin x. Okay, here trigonometric function, suppose sin x. Just we are trying to find the derivative of sin x. So f dash x equal to limit h tending to 0. What is our definition? X plus h minus x upon this. This is our definition. According to first principle method, f dash x equal to this. Okay. Now, just f dash x, that means derivative of this. What? D by dx of sin x. We can write also like this. F dash x, that is what? dfx upon dx. These are same. D by dx sin x. Fx means sin x. So just use here sin x. So limit h tending to 0. Fx plus h. Fx equal to sin x. So fx plus h equal to sin x plus h minus fx sin x. Clear? This. So this is equals to limit h tending to 0. Just our target is what? Finding this limit as h tending to 0. So we know about limit. What is the method of finding the limit? Some of the formulas you know. Okay. So here trigonometric formula can be used. Sin c minus sin d. Just like this. Sin c minus sin d is equals to what? 2 cos c plus d by 2 sin c minus d by 2. Just this. So use this formula. Sin c in place of c this is c, this is d. So 2 of cos c plus d. This plus this. What? X plus h plus x upon 2. This into sin c minus d, x plus h minus x upon 2. This upon h. Because our now target is our what? Finding limit of this quantity. So here h tending to 0. So here 2x by 2 means x plus h by 2. 2 cos x plus h by 2 into here sin x cancel h by 2 divided by h. So we can write h by 2 into 2 for setting. So now this to cancel out. So limit h tending to 0 to cancel. So cos x plus h by 2 into limit h tending to 0. This limit can be separated as a product. So sin h by 2 upon h by 2. So just we are getting like this. As h tending to 0, h by 2 also tending to 0. Since limit x tending to 0, sin x upon so here h by 2 and as h tending to 0, h by 2 also tending to 0. So we can write here also in place of h by 2. H tending to 0, h by 2 tending to 0. So this is same quantity. This. So on. So this is equal to 1 and here just we can write cos x plus 0 by 2 into 1. Cos h equals to 0 you can put here. So 0 by 2, 0 cos x into 1. So this is equals to cos x. So this is the derivative of sin x. dy dx sin x. Derivative of sin x is cos x. So this is by first principle method. First principle method means using this definition. We can get the derivative of a function as also another function of x. So dy dx sin x equals to cos x. Okay. So this method is called first principle method. Okay. As a similar process, we can find the derivative of 10x also. Just like see derivative of 10x. Okay, so how can we find the derivative of 10x? Here, just we can see take 10x. Derivative of 10x. 6 trigonometric ratios or trigonometric functions are there. We can find all the derivatives of all these trigonometric functions. So sin, derivative of sin x is cos x. Now suppose 10x. So our formula will be here what? In place of sin, there will be 10. In place of sin, there will be what? 10. Okay. Just as the same process. Now, here will be changes. Okay, the derivative of sine is cos. Similarly, cos, sec, cosec, cot, tan. You can find derivative. So here, the sin x derivative is cos x and cos x. Derivative of tan x. Just we are trying to find here. Tan x, limit tan x. So just do it by 1 by h is there. Just our target is what? Finding limit. So here we can find the limit 10. So just it convert it because we know formula as what? In terms of cos x, sin x by x, limit 1. So here just convert it in terms of sin and cos. So here what? 1 by 10. 10 means sin x plus h upon cos x plus h minus sin x by cos x. Just take LCM of this. Just now our target is what? Finding the limit. So solve it. We know whenever they are function as like this, taking LCM. Okay. So cos x plus x into cos x, and we can write what? Cos x into sin x plus h into cos x minus cos x plus h sin x into cos x plus h. Clear? This. Now here we see that sin a cos b minus cos a sin b. So what is this? Sin a minus b. Okay, sin a minus b formula is this. Clear? So limit h tending to 0, 1 by h. So we can write it as what? Sin a cos b minus cos a sin b. That is sin a minus b. This upon cos x plus h into cos x. This. Since sin a minus b equals to sin a cos b minus cos a sin b. This is sin a minus b equals to sin a cos b minus cos a sin b. This sin a minus b formula. Just use here. This is a, this is b. X cancel sin s. So we can set it like this. H tending to 0. X cancel sin s. Sin h upon h. First way. Sin h upon h. Sin h upon h into limit 1 upon cos x plus h into cos x. H tending to 0. So this is equals to 1. This is this limit. Sin h tending to 0. This. Since limit h tending to 0, sin h upon h equals to also 1. So we get what? After this line, just we are writing here, equals to 1 into 1 upon, this is equals to 1 by using this formula. And here h equals to 0 here. So cos x plus 0 into cos x. So 1 upon cos square x equals to sec square x. So this is derivative, sec square x. So derivative of 10x is what? Sec square x. This is equals to sec square x. Okay. So 10x, derivative of 10x is sec square x. Derivative of just sin x is cos x. We have proved these two. Now remaining 6 for 6 functions you can do. So do the practice for by using first principle method, finding derivative of what? dy dx, cos x, cosec x, cosec you can get convert it 1 by sine, cos, cosec, sec and cot. This for this for trigonometric function, just find the derivative by using first principle method. Okay, and send me the solution for your attendance. Okay.